Welcome to the OLM Working Group meeting on Thursday, February 11th. On the agenda today, we have a few items. We have items on multi-arch operators and catalogs and how to best evolve operators when the Cube APIs start disappearing. I wanted to start off the conversation to talk a little bit about organizing our feature delivery and sub-projects within this working group. This is something that we've talked about internally a little bit. Basically, what I was thinking is that we could potentially come up with some idea of sub-projects or maybe epics that are basically features that are implementable by members of the community, and we can help shepherd them along. Because I think this working group, we've been meeting for like 6 months. It's been productive in building relationships and helping with various support and other types of issues. But really, ideally, the goal is to bring some feature work in so that upstream community members can deliver the features that help the broader community. And I don't think there's enough continuity between meetings. And what I've seen in other working groups is that they basically have explicit sub-projects and they track them, and then they get updates on the sub-projects or initiatives. So I'm not necessarily talking about separate repositories or subfolders, but like if there's anyone in the community who has a project or a goal that we can sort of pin and talk about in every subsequent meeting, then we can basically go further in delivering and helping the community deliver the features that they're interested in. Like, I thought one of the issues that was raised during last feature planning meeting around like catalog observability or catalog differing between catalogs was a good example of a feature that was implementable, and we could sort of keep track of it. Now, how we keep track of it, whether it's through GitHub projects or another type of system, is a separate question. But basically, I wanted to float that idea of trying to track some initiatives for the working group, so the working group can deliver larger pieces of work. So how do folks feel about doing something like that?
Yeah, I guess this seems reasonable to me. Yeah, I guess just to make sure that whatever we do, we actually have a champion who can facilitate that and record that information. Because like I've seen a lot of other groups, like the sub-SIGs and things like that, that kind of, they start off with a lot of membership and they fizzle off, and it ends up being the one guy, who wanted to spearhead it. So it's kind of like at the mercy of whoever wants to lead it. So I don't see a problem with that.
Right. No, you're right. There will be someone who will champion it, and essentially it'll be like the typical feature process that we have, where we write an enhancement, people review it, and then it gets implemented. But the idea is that, like, in this meeting, we can shepherd along like concrete features and tasks. And so I don't know if there's anyone on the call who has something that they feel like they would want to add right now. If so, great. If not, maybe people can just go back and think about it and basically come up with a set of proposals that we can track.
I think a biggie that we can probably deserves, at least it's kind of a biggie, so it might actually deserve to be here rather than a subgroup, is basically floating the idea of, and I see Mike is here, and I think Evan was on this call on Friday we had with Red Hat, with IBM and Red Hat. We're talking about this and how we deal with these composable operators, where you have basically groups of operators. Like one operator, you install the top guy, he installs a whole bunch of other stuff under the covers. So you end up having this tree of things. And then we also have this problem where we have operands, and we have singleton operands, and we have to wire all those together too. So Mike had talked about, it's probably been 4 months ago since he demoed this, called the Operand Lifecycle Manager, Operand Deployment Lifecycle Manager, ODLM. And so we want to revisit that whole problem. How do we take this flat model and put it into a composable model? And is there opportunity where we want to elevate the operand model a little higher up? And maybe would that be something that OLM would make sense to control as well? So I'm not sure
Yeah,
what to
it's
call about that, but
like this notion of umbrella operators
yep,
is sort of
exactly.
how we describe. Okay.
Yep.
Yeah, I mean, that's definitely like a, right, a complex area. Um, so just to be clear, by sub project, by subgroup, I didn't mean like we would actually be in it wouldn't be like a smaller group or anything, or like a separate meeting. I'm just saying like in this call, we would track it as this like a sort of initiative. That's sort of what I was referring to. So that can be an example of an initiative. Like that one is a good example, but again, that's a fairly complex and nebulous sort of uh challenge, but we can address that if that's something, if that's of value to you and to the community. We can basically track it a lot, like in every working group call, like where did we get on this, how do we feel about this, is there any movement on it. Some of the other ones that folks on this call have brought up are a little bit more actionable, like in the sense that I feel like they're more likely to be delivered. That one is, if that's important and you or you said Mike or someone wants to champion that we can do that. Yes, the goal is to structure. I mean, the goal is just to ideally enable members of the community to make more progress, because I feel like we make progress definitely in the sense that we build up the community, we address people's needs, but it's a working group, and we want to work to deliver things. But it's not like anyone has to do anything, or there's any dates or anything. Like nobody on the call has to do anything. It's just like, could we sort of empower people to deliver larger things? Because to do that, you need to track it, right? Like you need epic, you need stories, you need like some organization around it. What I feel like is generally in every one of these meetings, we kind of start off with a blank slate and we go and we discuss things, and that's great. But then, from what I've seen in other groups, it's like there's a few things that are like sort of incrementally making progress, in terms of features or. So I was wondering if
Yeah,
you
I
wanted to
think
adopt.
so. Right now, I don't know, for me being an outsider, so I still consider OLM being a Red Hat driven solution, because there's still a lot of Red Hat things that happen behind the scenes. And so I guess if there are features, like I know, for example, the declarative index, right? So that's a big feature that is being worked on, right? And I
Right.
think you guys are probably having feature discussions on that behind the scenes. So that
Right.
to me seems like that should be something that's elevated that you could invite us to if we're interested in seeing behind the curtain. And there's other big features that are coming down the road that I know of too, which should be helpful. Maybe you have a substream based on each of those larger features that you're working on, and maybe we can springboard it that way. I don't think anybody else from my side, from IBM anyway, feels empowered enough to be able to create enhancement requests and understand the source code. Right now, we're doing testing. We're writing a bunch of test cases and stuff to exercise the use cases we have to make sure there's no regressions and things like that. So I think it's a great starting point.
Okay. Could you maybe elaborate a little bit on what is sort of missing? Is it simply time, or like the complexity of the code, or because I think that ultimately it was sort of one of our goals. It's not, and not necessarily towards you and your team, but in general, like anyone who's on the class should feel like they can approach it and make an enhancement. And if it's something that benefits the broader community and doesn't conflict with the roadmap that we have, then they should be able to implement it, and everyone should help them implement it. That's kind of the goal of the working group, I think, to some degree.
Yeah, yeah. I guess it's just only because of time, right? And
Time.
so we don't. Our full-time job isn't working on OLM. I'm not sure if that's your full-time job either, but for us, working on OLM is more of a user of OLM and a consumer of OLM, and we drive requirements into OLM, but we're just getting started being committers. right? Because we're committing to other stuff for our own products, and OLM is basically a delivery mechanism for those products. So it's really kind of us getting our priorities kind of adjusted so we can actually dedicate, and we're dedicating more time. So I can see Jay and John Hunkins are here, and they're actually working on, delivering code, but it's test case code, not actual runtime code.
Okay. Yeah. All right. So, I mean, it seems like maybe maybe we're a bit early on this. Maybe we can revisit this topic in a few months. I just want to throw it out there.
Like I said, right now you guys are doing this already, right? But you're doing this closed.
Right.
Right. Don't open it. Open it up so we can be involved in that process. And then I think that could be a good start. So we can actually see what some of the development things are going on behind the scenes, and we can help participate there.
Yeah, I mean, go ahead.
Yeah, I was just gonna say, I feel like that there's a definite advantage to being able to, if you have features that you'd want to, expose as a something that we can all look at, opening it up so that it's more visible, so that we can actually see what you're actually planning on, what your roadmap is, and what kind of features you're looking at implementing. That could be useful for us to be able to say, "Oh, wait, that's something that we need to do too. So let's see if we can pitch in on that." And so, raising the visibility, I think, is important too. So
I think you guys are working on that, and it's definitely helping. Adding milestones to decoupling OpenShift from upstream. That's great. Using milestones and feature planning and triaging, all that stuff. That's all great too. But the actual design work, and what happens is I think you guys do all your design work and because you guys have real deep understanding because you've grown up with this. And so you do a bunch of stuff behind the scenes, and then that kind of morphs out to a document, which ends up becoming, this is how we think we're going to do it. What do you guys think? And then it usually takes us a little while to get into that. And then by the time we have actually absorbed it, then you've implemented it. So it's.
Yeah, I mean, I think that from our perspective, everything is sort of transparent in the sense that the Jira is open, the GitHub is open, the enhancements are there. But you're right in that we can try to be more transparent maybe in this meeting. I don't know, Kevin, do you want to speak to?
I don't think the Jira is open, by the way. I think the Jira is still closed. I don't think we see everything in there.
I believe it is technically open, but by default, they didn't like whoever the Jira admins were or whatever, didn't enable all the existing stuff to be viewed. So it's like we need to actively go into each and every little item and turn it on one at a time.
Yeah.
And I don't know, I appreciate, I think OpenShift in general is sort of this goal of let's make our project planning more out in the open and use the existing tools we have to do it. I think that's a noble goal. I don't know that goal necessarily satisfies this internal project's or this external project's ability to actually track what the project wants to work on, right? Because anything that's going to be upstream specific, it's just not going to show up in the upstream Jira or in the Red Hat Jira. So to me, it feels more like what we actually need is some kind of more explicit tracking. I think that's what I kind of was initially sort of trying to get the project to work towards by using milestones and issues. We haven't really done a super great job of making that process really, really explicit. And I'm wondering if what we really need is I don't know, start using GitHub projects or a Trello board or something that shows more explicitly, here's the stuff that actually needs to get worked on by the community. And if somebody's working on something, they can, tag themselves as actively working on it or whatever.
So I have a quick question on this topic of things are moving too quickly. We don't seem to have a grasp on things that are changing until they're already changed. So are basically what you are saying is things change in OLM that directly conflict with how I want to use OLM, and I don't have any say in that process? Or you want these changes, you just don't have any time to give input?
It's the latter. And it's not because you guys are moving too fast, it's because I move too slow. Right. So it's really, I I think for some features, we're kind of given an idea. It's like, I'm trying to think of what's a good example of one. It's like you've given us the index, what is that? The declarative index. I've known about that now for a month, but I still haven't had a chance to take a look at it yet. It's on my to-do list. I'm spending the majority of my time, in my team's time, we're spending majority really finding edge cases, and this is why we're writing test cases. We're spending all our time just trying to use OLM the way it is, and then trying to figure out whether we have deficiencies in OLM, which require features, or there bugs. What are we working around? We're trying to develop an entire corporate taxonomy and an opinion about how to use OLM, right? Because OLM's a tool, right? And so we're trying to make it so everything works the same. And so we're trying to develop a layer on top of it, per se. I'm trying to think of another example. I think there's an example coming up, like the de-scoped operators. That's another biggie, right? That's going to have huge ramifications on us. And so it's not really it doesn't seem to me like we know if it's really coming or not, but then I've heard other arguments that say, oh, yes, it's definitely coming. So just go ahead and start not using namespace scoped, OLM operators anymore. And so those are the kinds of things that we've had cursory discussions on, but we've never really seen a lot of the other drivers behind it.
Yeah. And thank you for saying that, because that's like something that I've definitely been aware of. Like I'm not involved in OLM on a day-to-day basis, but on the operator SDK side of things, like I do work on the OLM integration. And I have noticed that myself, like I'll even look through the enhancements repo and be like, holy shit, there's, so many different things that have been done recently. And I mean, I'm working like within the operator framework aggressively. So if I'm not seeing these things, then neither are you. But I will say, I think this is like a two-part problem, and it's not really a problem. It's just one part is operator or OLM is still like not 1.0, right? And there's a ton of stuff that is being derived from user feedback within Red Hat, the OpenShift org, and the community that is being formed into these ideas that become EPs. And because there's just been so much feedback and OLM is so useful, I think it has been a lot. And we are condensing these things into these EPs and like making steps towards getting to where the feedback for features decreases to the point where I think a 1.0 is viable. And then the other part is like, I don't see very good documentation for a lot of these things, like even creating bundles and index images yourself. Like I still have to refer to the docs in the operator registry repo, which are outdated and not super informative. And then I don't think there's a lot of comprehensive documentation in the like OLM subdomain of the operator framework website. I also think that isn't from lack of trying, and that's just because like OLM moves really quickly. And they're also trying to move towards much more stable, lower surface area APIs and mechanisms to interact with OLM that make a lot of sense and are ergonomic. So I think that is also going to improve a lot with the more time that OLM is given. But those two things being said, I really do think a 1.0 roadmap would help the community at large understand what is going to be happening and what like overarching features need to be added to OLM before that happens. And then once a 1.0 is out, I think developing that layer that you're talking about on top of OLM is going to be a lot easier because there's already a feature set guarantee and technically no breaking changes should occur.
Well, even though you say OLM isn't 1.0, it really is, right? So at least OpenShift treats it, as a first class supported long-term support system, right? So from upstream, I can see that, but really it is treated as a 1.0.
It is, but I think that the ultimate goal for the APIs from a packaging and production standpoint are not 1.0. Like it's not like they're going to break old versions of OpenShift, but the ideal method for interacting with OLM and the packaging system does not exist yet in its 1.0 form.
Yeah, I have to very strongly agree. I would argue that the only reason why, there are any kind of support guarantees and all of that stuff is because OpenShift has rules about if it ships with OpenShift, then we have to support customers, not because there isn't and shouldn't be churn on our APIs, because I think there has been and continues to be. I think just from the perspective of like what the state of the project itself is, it's not really what I would describe as a 1.0 yet.
I have started a document that I've not shared yet, but it's sort of a vision for what 1.0 OLM looks like. I'm happy to go over that with this group here, but just I would emphasize that it's my opinion, and it's not like it's nothing set in stone or anything like that. It's just like this is where I think all of the ideas we've been working on end up in a good final state to be a project that's like long-term supported with less churn.
Yeah, that'd be great to see, because I think I've been working with OLM pretty solid for about a year now. And I think I finally understand it. It's taken me that long. And I think my team and all my products, I think we're starting to understand it well enough. And so now I think we could probably actually, if we looked at that, we could see maybe where you're coming from. Because obviously you guys are the experts. You've been working on it for like 3+ years.
Yeah, I'd love to see that too.
I'm happy to just share it now, as long as we're all willing to take it as it stands, as this is just my opinion, and haven't gone through any sort of reviews with this crowd at all. So I guess
you are on record saying that. So
okay,
good to go.
Excellent. We're recorded. Let me find the screen and I'll share it. All right, can you see this?
Yep.
Cool. So this is kind of like my notes on what I thought 1.0 looks like. It's internal, but that's not Red Hat internal. That's like, I don't think this document makes sense to someone who hasn't spent a lot of time with OLM and maybe has developed OLM before. That's the internal that I mean. So it's mostly just kind of like a set of initiatives that I want to see through to the end, and then what I think the components look like once we've followed those through to the end. One is this migration to descoped operators that we've talked about briefly before. What that looks like for OLM is really more like OLM gets out of the way for the most part. And when a user sees an API in the cluster, it behaves the way Kubernetes APIs behave. So most of that is not so much explicit work in OLM so much as it is guiding users in how to write operators that work the way a user could expect it to. So I think we have a lot more discussion on all of that, but that's one direction I want to go, because I think a lot of the UX problems that we have right now are related to scoping and all of the related namespace and RBAC issues that come with that. The other one is the declarative index config. That's already in progress. We have that enhancement that is pretty much ready to go. And I think this solves a lot of our publishing side problems. Another is an independent resolver. So we did a lot of work last year on the resolver to make it a good foundation for a lot of other future work. But one of the things that I don't like about it right now is that it's still very much embedded in OLM. It really doesn't need to be. It's a useful component on its own. It's useful to run it off cluster. There's lots of interesting like GitOps workflows that would involve using the resolver standalone, or even for other unrelated projects, because there's nothing in the resolver that is OLM specific. there's just like a wrapper layer around it that is OLM specific.
If you could, yeah, one thing to add to that is visibility into that thing.
Absolutely, yeah. We have a few interesting things that I think we can do there, visualizing it, and even things like some sort of a REPL that lets you query against catalog content. But I think that makes more sense if the resolver is an independent component.
Yep.
Independent and pluggable bundle unpacking. We have discussed this at multiple times over the past couple of years, being able to have other bundle types. We've spent a while, a year and a half ago, I think, looking at Helm as a bundle type. And this is where I think some of that ODLM work might be intersecting here, because the goal long-term is to be able to support other types of artifacts that are not just things that we consider operators. Operators are the hardest artifacts to work with because they have all their cluster extensions, and they have all these rules around what they can and can't do and how they should be used and how they should be updated. And they need to.
They have their personas, right? Which kind of persona is dealing with it at what time?
Right, exactly. But I think it would be nice, for example, this is kind of our like straw man use case. It would be nice if I write a Helm chart and it uses a Prometheus CR, and then I can plop that in a bundle and say that it depends on the Prometheus operator. And that opens some interesting workflows on a cluster or off a cluster for, if a user is an administrator that's applying that, or if a user is not an administrator, and that triggers like some requests to install the Prometheus operator for someone who can. But making all of those decisions, that's again sort of an independent thing, right? Dealing with different types of bundle artifacts and how those get applied to a cluster and how they get managed and distributed. That can be done orthogonally to, the runtime component of OLM that gives you information about the safety of running two operators that manage the same API, for example, or orthogonally to the resolver itself.
So have you looked at CNAB at all in that context?
I have looked at CNAB. It's been a while, but there were some things that I thought were a bit of a impedance mismatch at the time. It's definitely worth taking a look again and see if that fits into this as well.
Sure.
I guess, and then yeah, the last one was that our entire on cluster update infrastructure should really be optional, because there's lots of use cases where the live update is not what you want. You want, any GitOps flow doesn't need that component and even running, right? So I think that's worth looking at. So I think that kind of leads to a set of independently useful components potentially that are not, that together would make up the OLM or the operator framework story, but which could all be used on their own as well. So I don't know, that's where my head is at. Like I said, I think maybe a couple people have seen, I know Kevin's looked at this before, but it's not set in stone. It's just where I think it makes sense to go.
That's reasonable. This is helpful.
Yeah, thanks for that, Evan. Really interesting. So with that, I didn't mean to hijack the meeting today, but let's get to, unless anyone has anything else to add, we can get to some of the other things on the agenda. So next up is multi-arch operators and catalogs by Chris.
Yeah, so we noticed a Bugzilla in OpenShift, and I think Evan, this might have been yours. Basically talking about multi-arc operators. So the problem we have is that yeah, we basically all of our products support three, the three main architectures, AMD 64Z, S390X, and PP and PowerPC. And so, but typically customers are using just one of those. And the problem with Docker, manifest lists is they're all or nothing when we're dealing with multi-arc images. So I wanted to find out if we should be moving away from manifest lists for the operands and operators and the bundles, and instead of having just maybe a manifest list for the top level operator and then having separate catalogs. I'm sorry, manifest list for the top level catalogs, and then having single arch images for each CSV. So you'd have basically a CSV for AMD 64 that would only have the label in it for that inside that CSV. And we'd have basically an entire tree that would just be the entire tree would just be per architecture. Is that what you guys are imagining on being able to support that? Since now it looks like the feature that Bugzilla has, that bug had, and it was basically to deprecate the old the mirroring tool, which just happens to be an OC. Instead of mirroring the entire, trying to carve out a specific image of there, now it's actually going after one specific architecture within the multi-arc image. So really the question is, should we abandon, bottom line, should we abandon multi-arc images for our operands and operands, the manifest list? Should we abandon those and just go with direct architect and then having architecture specific catalogs?
So I think that it's worth mentioning, and maybe you're already aware of this. I think kind of you said it based on your response, but the only thing that actually doesn't work here, all of it works fine if registry supported actually mirroring manifest list images without all of the underlying images included.
So basically, yeah, you'd have a manifest list pointing to images that aren't actually loaded on the registry.
Right. Like if that was possible, this would just work.
Right.
As it is, basically what we're saying to all of our OpenShift customers is like, okay, if you want to mirror stuff for your architecture, that's fine. You have to also mirror all of the images you don't and will not ever care about as well for this to work. And we just say, go do that. And it works fine. So the improvement here, if we wanted to try to do something else, would be purely for storage reasons, which I agree. It's definitely like something worth investigating. I don't know that we have spent, I mean, Evan, you can correct me if I'm wrong. I don't know that we've spent a bunch of active time trying to necessarily solve that problem. We only found out it existed like, I don't know, 6 weeks ago. So you could you're definitely right. Like it is definitely possible for you to curate explicitly manifest or architecture specific index images. It just means a lot more work on the build side, right? Like everybody's either got to know that they need to keep track of multiple separate CSVs, or you need to build some kind of infrastructure that swaps the related images and all of that fun stuff. Yeah, like I said, I don't know that we have a specific, like, this is what we think you should do. And it does seem solvable. Like this seems like something that we could make an improvement on in the like Docker registry spec, if that was something that could be,
right,
contributed to, but we don't have an answer right now.
Yes, as far as you're aware, is there any work going on in the OCI or Docker side of things to work to deal with that at all?
I'm not aware of any.
Yeah, I haven't seen anything.
But we haven't taken this problem to like the OCI working group and discussed it yet. I could see a pretty reasonable argument that you don't want to allow manifest lists that point to content that doesn't exist in the same registry,
right?
Which I suspect will be the argument. So I'm not sure if that's actually in the spec or not, or if that's just a choice that registries make. But even if it's a choice that registries make, then that's that's a lot of documentation and support to get to a customer who's trying to do mirroring, if that makes sense.
Yeah, I mean, so the whole thing with digest is fragile anyway. Just all the problems we found in Scopio and Podman, and because registries, are a little sensitive to, white spacing and JSON files and all sorts of things, right? So those digests like to break easy. And we're finding that all over the place. So I think probably the real solution is probably to come up with an alternative to other than digest, like using unique tags, right? Tagging naming conventions and things like that. And the only reason we're doing digest at all is to support, to be able to do air gap in OpenShift. That's really our number one reason for doing that. And now they have reasons for not supporting unique tags, which I probably should revisit that again too. But if we wanted to fix this in Docker, I mean, I can imagine a new type of manifest list, like a sparse manifest list or something like that had different connotations. Which is gonna be that'd be a big sell, right?
We could also talk about features that let you, in the index say, this is my x86 version and this is my PPC version. I think that makes a lot more sense with the declarative config as well. That's kind of like one level down from maintaining multiple Arch specific indexes.
Right. Yeah, this isn't a showstopper for us because right now we're just telling all our customers to mirror all the images over, because we don't have that many images yet, but in a year from now, it's going to become pretty cumbersome.
Yeah, and for what it's worth, I think Arch specific indexes is probably the best user experience you can give for users, unless they're running like heterogeneous clusters that have multiple arches multiple worker node arches that they want to run stuff on.
Is that dumb question? Because I actually don't know the answer to this. Is that even supported? Like, can you do that in OpenShift today?
At various times, I mean, it's absolutely supported in Kubernetes, but at various times, I've heard different support statements around that. I think the latest is you can have a different arch for your control plane nodes than your worker nodes, but all the workers need to be the same.
Well, you can have Windows workers, right? That's a different set of container entirely.
Yeah, I think they like shim something to make that work. I'm not sure it's like, I don't know that works the same way at all.
Oh, okay, gotcha.
I mean, I would definitely be interested in talking about options that make the multi-arch story better. Like I said, by potentially tracking Arch data on the packages themselves in the index.
Yeah, I've got a kind of a murally proposal I'm kind of putting together. Maybe I'll share it with you guys once I have it written, just kind of to vet it out. I don't see any reason why it's not going to work, but I guess I just wanted feedback to see if it kind of fit within what you thought. Based on that feature, it seems like it did. And make sure, just make sure there's nothing coming I'm not aware of. Doesn't sound like there is.
No, the way it works right now, it works that way because that's how the current Red Hat pipelines ship multi-arch content.
Right.
But that doesn't mean that if you're building a separate pipeline without those constraints, there's probably a lot better you can do.
Right. Okay.
I'm happy to talk about the digest stuff a bit if that's helpful too, because I did end up in a conversation with some of the folks that worked on image content source policy just yesterday.
Okay.
If it sounded like there were questions about that, we can.
I mean, I know all about it because So we do things a little different than you guys do. So we actually have digests from the very beginning. As soon as you build something, all of our image references from that point on use digests. So we are Scopio copying every image from registry to registry from that point on. So that very first image has to be a V2, S2 image, can't be an OCI image because customers might not have OCI, all sorts of things. That's kind of the tack we took, versus trying to manipulate all the image references later on in the cycle, which is what the OpenShift marketplace does. So we don't really care about where the references are in the CSVs and all that kind of stuff, because we have the digest up front. We just have them everywhere. So the problems we've been having is simply around tooling, because we keep running into we run into various bugs between compatibility with Quay and Podman. We run into bugs with Scopio not supporting some security mechanisms we use. Just weird little things like that here and there. And they slowly get fixed, or we find workarounds for each of those. But we've got this real narrow, happy path of all the tools that end up working in all our environments.
Yeah, and I think the thing that bothers me the most is that there's nothing like image content source policy upstream. I mean, there is if you're using Cryo, but I don't know of any other Kubernetes distributions that do use Cryo. So
we've been having to use Podman in all of our tooling, so we can use the mirror conf file, which Cryo gives you. So.
Right. So, I mean, is anyone aware of any solutions for mirroring content in a non-Cryo cluster? I know that like Containerd has configuration for mirrors, but I don't know of components that configure it at runtime the way the image content source policy does. I think that's I think we've gotten a couple of issues on the GitHub repo about, how do I do an air-gapped install? And I think we don't have a good answer if you're not using OpenShift, because I'm not aware of any of the tooling to do the mirror configuration for non-OpenShift clusters.
Yeah, we only support air gap on OpenShift right now because of that.
Well, if no one knows of anything, I'll just take that as another thing to look into and see if I can find something.
Keep me in the loop, man. Curious about that too.
Yes, and we're definitely working on mirroring stuff as well on our side. Various bugs. So is there anything else, or we can move on to the next topic here? We have about 15 minutes left. Next topic is how best to evolve operators when Kube APIs start disappearing, also by Chris.
Yeah. So yeah, there was a little discussion and an issue I opened up yesterday. So yeah, as some of we're like the common scenario right now that people are starting to use, who are just getting into operators, they use the API extensions V1 beta for the CRD definitions, and then so now they're moving to V1, and so V1 CRDs can't be installed on OpenShift 4.4, and so our products will support 4.4, 4.5, and 4.6 all simultaneously. And so I'm trying to figure out what the best way. So there's a couple of questions in here. So number one, I wanted min-kube version as a simple way just to prevent the customer from accidentally trying to install a version. So I was hoping the SAT solver would block that, but it doesn't. It turns out to be one of these little things on the edge, which doesn't get enforced until after it's been chosen as a candidate. So you only see it as a pending install. So you have to unwind that after that happens. The other thing I just tried, and it seems to work, is I can actually use an API service definition with the required as the API extensions V1. And that appears to block in the SAT solver, just like the custom service definitions are required allows. So it's led me to some more experiments to try to figure out, okay, as an operator comes out and they keep introducing new features into it. What's the best way that we should be containing those features in a graph from a compatibility perspective? So let's say, for example, I know Kube is going to be removing some APIs, and I think, Evan, maybe you might mention what they were, and I can't remember which ones they are, but I think there are some APIs that are going to just actually be removed. And so at some point, we're going to want to protect ourselves, prevent, OpenShift from OLM from just blowing up when trying to install these things. We'd want to actually block it at the SAT solver level. And so I'm just trying to figure out what is the best way. So if an API is going to go away, should we be continuing down this road of segmenting our catalogs by Kube version and having some kind of tool to make sure if you're going to upgrade from this Kube version to this Kube version, which we demoed last week, what would this thing look like, to kind of do a dry run between this catalog and so forth? Or do we continue adding more metadata and labeling kinds of things to the actual CSVs to say, oh, this CSV now has, it's got more constraints on it because it's been evolving and it used more APIs, or it needs other features of which can be arbitrary. So I'm just wondering, how far do we go down with the multi-catalog thing versus, because I know the declarative index, which I still haven't reviewed yet, is going to add more of this. Do we add more information to the CSVs and the index for that? Are you following where I'm getting at? I'm just trying to figure out. So as you move, like as we move an operator, forward in time, and APIs get removed or changed, what happens? What's the right way? Is there a prescription for how we should be dealing with that? We've been dealing with adding stuff, but not deprecating and removing stuff very heavily yet. And we're going to have to, jump on that pretty quick.
Hey, Chris, this is Fu. I would like to say a couple of things here. Though it seems like if I have answered all the things you said, it's going to take me a while. So let's begin with a few things that you mentioned specific here first, and then hopefully that will be at least somewhat helpful for you. And then I assuming someone else will want to jump in a bit later, answering a couple of things. So first of all, the mean Q version, and we were talking on the issue already that it wasn't meant to prevent the installation, as you reported it out. It's essentially prevent the operator to get to the specific state, meaning get to the point where it can be used, essentially, can be serviceable. So it doesn't prevent the installation. And obviously that's going to be a problem if you expecting certain API or expect to install certain component that will not be able to, not compatible to that cluster. So it's going to fail in the step where you try to installing, for example, V1 CID in the cluster that doesn't support V1 CID at all. It's going to fail at that step, let alone to the point where checking for the min Q version, right? So that is the problem at first. And then it seemed like you mentioned about the required section of the API definition required and CID requirement on the CSV. Actually, there are another field that not really commonly used, and I think that was meant to be used in this case actually the native API. That thing haven't been mentioned for a long time. Evan can talk more about this. That actually, I think, originally intended to actually checking for certain API that be installed with the cluster that you can actually require or check and stuff like that. But I will let Evan talk more into that area if that's something we even use anymore. I don't remember specifically. And now go back to the problem that you have with the fact that when certain API being deprecated in Kubernetes, how you can possibly managing that when you basically having an index that support multiple different versions of the cluster. And at the moment, it seems like the common way to do this is basically, like you said, that make a separate index for separate version of Kubernetes to make it everything completely isolated and specifically compatible to specific version of Kubernetes. And you will never need to worry about some incompatible problem. But it's work if you specifically design a pipeline to doing that way, but it doesn't work if you try to mixing one thing to the other. It doesn't actually work out that way. And I think we were talking about at some point to having certain label or property that represent certain property, call it that way, or certain kind of like internal cluster-based information that can prevent installation from happening from the first place, not letting the operator being installed and fail. It should supposed to be gatekeeping that thing and rejecting the installation right off the bat to avoid getting to the failure state. By the time you get to the failure state, you already know what's happening, right?
Yeah, so it feels
Go ahead,
like,
Chris.
yeah, it just feels like that every constraint that you might have on your operator should be decorated, right? It should be metadata on the CSV, right? Not on the package necessarily, but the CSV. And then it seems like the SAT solver, as it's trying to evaluate things, would give you very clear clarity on what it can and can't operate. So right now it gives you like upgrade pending or upgrade available, and then it just doesn't happen. Or it blindly upgrades you, and then you're stuck in this pending state and you have to figure out how to unwind it. It seems like you need a way to say, oh, upgrade pending, but these dependencies are not solved, right? So these dependencies are not available. It just seems like you need a lot, and I've been talking about this for months now. We need a way to have that visibility, but it seems like it'd be, by separating that out into separate catalogs, you're not going to have way too many catalogs, because now you have to have catalogs that handle combinations of things. Oh, and I have AMD 64 that needs this version. I have AMD 64 that needs this version. So now you have this, Cartesian product problem, right? You're going to have a proliferation of catalogs.
Yeah, I'm just
So
saying that the current solution is different catalog sort, but I don't think that will be the way moving forward, because
Okay.
You cannot expect everyone to just continue to create separate thing forever. It can be difficult to managing when you're having separate thing and you need to keep track of what thing was, and if you need to mixing them up, it's not gonna work, and it's create more problem in the long run. So I think that the solution is the like you said, the resolver should be able to tell what operator is compatible with the current cluster that's running in. The problem here is that from your perspective, you can certainly adding certain attribution to the bundle, basically to the specific version of an operator, right? You can having a label stuff that we support, it's not really publicly supported a lot. And technically speaking, I thought in the past we were planning to allow you to basically providing like add into the bundle a file to let the OM know what property you actually providing or you requiring and stuff like that. So there's a way to do that as well. I think it's not really done yet, but that's something we can certainly do. But the problem here is the fact that OM is not yet aware of what the cluster is capable of, or what is the cluster restriction or limitation is, if you know what I mean. Like OM doesn't actually, it do that when it check for requirement, checking for the min-q version, it can actually tell which Kubernetes version this cluster actually is, but it's not yet projecting that specific information at the requirement for the operator to be installed yet, if you know what I mean. It checked at the requirement. If it's not, the resolver doesn't actually get the information yet to filtering out the operator that doesn't actually fit into that specific Kubernetes version. So that is something need to be addressed. You see what I'm saying?
Yeah, Evan was kind of saying, hey, it's kind of feature-ish, right? So I get that. It just happens to be something that wasn't in that particular particular part of the code, that particular part of the design. I get that. So what about the idea of having, so you had mentioned that API, I can't remember what it's called, the
native API.
Yeah, so
I think Evan can speak up a little bit about this.
What I thought that was just basically doing an API resources, API versions, just to see if the aggregation API exists, even if it's not hosted by a CRD. That's why I thought that was.
So the field that you referenced, the API service definitions, is a quirk because we added support for depending on API services after we added support for depending on CRDs. So if you have an operator, maybe this isn't commonly known as well either, but you can write an operator that doesn't use CRDs and instead uses API services directly, and that lets you specify that we shouldn't be checking for specific CRD properties when you need that dependency. We should be looking for just the presence of that API. So it's very similar to the CRD check. It's actually less strict because it doesn't check for the presence of a CRD with particular properties. It just checks for the presence of the API in the cluster. But the difference is that if you specify that requirement there, that tells OLM, oh, we need to go find something in the catalog if it's not there. Whereas this other field, native APIs, that's where you can just list out all of the APIs that you use from Kubernetes or from OpenShift. And OLM will block if those aren't there, but OLM will not try to go find them from a catalog somewhere because we expect that to be part of the platform and not something that's provided elsewhere.
So that seems like the exact right spot to put any APIs that you need from the platform.
Yes.
It seems like we should be putting the CRD v1. That's where we'd put that. Hey, we're using these CRDs. That's where you put it.
Yep. I think that we probably will do something that automatically fills all that out on the index side, just because once Kube 120 releases, that's going to be an issue across the board for every operator that's released before v1 CRDs.
Yeah, you had mentioned 120 was removing some stuff, and I looked in the release notes and I could not find what you were referring to.
Sorry, I think I'm mixing up. I think it's 122.
Okay.
22.
Yeah.
They mentioned that in the common section in the code on Kubernetes, and that way it is. I can look it up for you. But
Okay.
that way it mentioned. But
All right,
22 is correct.
Yeah, because 120 is like right around the corner.
So I think we've been talking about like the installation side of it. If you don't have an operator installed yet, and I go to install it, right now you don't find out that it would fail until after it's installed. Who described that, and also how we would like to put that into the resolver so that we just don't even attempt to install it. But I think you were also talking about the problem of if I have an operator installed and then I upgrade Kubernetes underneath it. Is that what you're, okay.
That's one of the scenarios, yep.
So it's interesting to bring that up in this context, because I don't know that we've put a lot of thought into this for non-OpenShift clusters, because non-OpenShift clusters, or at least as far as I'm aware, don't generally have a component on them that manages the self-upgrade. Most use an external tool to do that.
Right.
And it's really kind of in the purview of the tool doing the upgrade to understand some of that stuff. So if your target is OpenShift clusters, the way that we're planning to solve this problem is to include an optional max OCP version annotation on operators. And then because we will have the declarative config, you can come in after the fact and update any operator's max OCP version after it's been published. And so as we're getting ready to upgrade an OpenShift cluster, we'll have OLM will check all the currently installed things. We'll know that it's running on OpenShift. We'll check to make sure that everything currently running supports the version we're bumping to. And if it doesn't, we'll block the update, and an administrator will have to come in and override that block if they want to update anyway. That's kind of how it works in OpenShift. For non-OpenShift clusters, I think we just need to do some requirements gathering, because I'm not really even sure, aside from like COPS and KDM, if there's any standard around updating.
Yeah, okay, interesting. Yeah, okay. I don't feel any better. But I think we've still a lot of work to do to kind of try to solve some of these things. But I do feel good that at least that API, it sounds like, it's not common to use, because I haven't seen any examples of it used, at least the CSV option. But I think we can use that at least to get out of jail for a few of the edge cases. Okay.
So are the clusters that you're concerned about, are they OCP clusters, or are they Kubernetes, or what's the context?
Yeah, OpenShift is really the target platform for all of our workloads, but we do have some that do generically on anything. So they will have this problem.
And how are the updates managed on the non-OpenShift clusters?
That I don't know. I really don't care. I really care about OpenShift for the most part. So I think I can't remember. My memory is short. I know Joe from my team demoed. I think it might have been last week. This tool that he's kind of prototyping, which is going to allow you to compare an or a cluster, not necessarily OpenShift, with a catalog, and compare it to another catalog, and find out what the differences are, and find out if I were to apply this catalog to this version of this version of Kubernetes, or some future version of Kubernetes that might have these things, then we can kind of find incompatibilities. So it allows us to do kind of a dry run.
Yeah, that seems really valuable. It sounds like a really useful thing to have in the toolbox. It does sound like someone's going to need to do the maintenance to keep the list of things that's supported on each target.
Right. I want to make it be able to work with based on these labels, right? If we get this label thing done inside the declarative index, that'll help. Then we don't have to have so many catalogs. Just one quick question. Are you still working on the conditional grouping for the dependencies YAML?
It is not, I don't think we have an explicit design for it, but yes, that's something I'm very concerned about, the fact that we don't have that.
Yeah, because we can't use the labels until that's there, because the labels need to work in conjunction with the other constraints. Know what I mean?
Yeah,
Yes,
we haven't had a enhancement for the combination constraint
Yeah, it was
yet.
in the
even though we're planning
roadmap
to do.
for, yeah, it was in the roadmap, I think, for 4.7, and I know things changed to try to get some stability things in there. So I was just wondering if that one snuck back in, but looks like it hasn't.
I was hoping we might be able to sneak it into the declarative config work, but
Okay.
that's not really fair since we haven't written it down. So,
All right, bummer.
All right. We're already 5 minutes over. Thank you everyone for a productive meeting, and see everyone at feature planning next week. See you guys.
Yep, thank you, everybody.